Well, they're back. Trigonometric substitutions. Alright, during the first portion of this video, we're going to go over the key to solving these problems. We're going to go step by step on what to look for, what to substitute, and how to always check to make sure you're on the right track. And then the second portion of this video, we'll do a simple-ish example on how to actually solve one of these through. So for the key, we have the first section, which is given. What are we given? There are three cases when solving these problems. 1, 2, and 3. The first one is a square root, and we have a squared minus x squared. Second, we have a squared plus x squared. And lastly, we have an x squared minus our a squared. Okay, so the second one is our substitution, what you will actually be substituting in the place of what you're given. So whenever we have the square root of a squared minus x squared, we are going to replace x with a sine theta. A sine theta. Moving on to the square root of a squared plus x squared, we're going to substitute a tangent theta. Lastly, x squared minus a squared will give me a secant theta. One more column in this. One more column. We have a check section. Check. So whenever we do use a substitution, we can always check our answer. So if I'm using a sine theta, this will always give me a 1 minus sine squared theta, which will equal cosine squared theta. All right, for tangent, we are always going to get a 1 plus tangent squared theta, which equals secant squared theta. And the final one is a secant squared theta minus 1. He's always the hard one to remember. This will give us a tangent squared theta. All right, if you follow this key, you are bound to get the right answer. So, step 1 is always looking at what you're given. So let's just do a simple little example. I'm not going to solve this one all the way through. So we'll work with what we got. We're going to do an x over the square root of 9 minus x squared dx. Okay. In this type of a problem, what we're looking for is specifically what is a and what is x. Well, x is obviously x. 9 is our a. It's our constant in this case. So, which one do I have here? Do I have case 1, case 2, or case 3? So I do have case 1. So that tells me everywhere I see an x, I am going to substitute a sine theta. But what is our a? Is it 9? It's not 9. Because we don't have a square root here, we have to actually take the square root of 9, which will give us a 3 sine theta. All right. So that's how we identify what our a is going to be for all of these given problems. We're always going to take the derivative, so whenever we have an x, go ahead and take your dx. This would give you a 3 cosine theta d theta. Okay, I don't know how to stress this enough. I'm not going to yell at you, but this is so important, so important. Whenever you have this problem, you always have to replace your dx at the end, so this guy, with this. So this has to be replaced with your d theta. If you do not do this, you will always get the wrong answer. So it is a must. So whenever I plug in everywhere I see x, plug in your x, and then at the very end of it, replace dx and multiply on your d theta. Okay, so let's dive right into our first example. We're going to try to break this down as easily as possible. So let's do, we have the integral of the square root of x squared minus 1, all divided by x to the 4th dx. All right, so, this looks pretty bad. I'm not gonna lie, it looks pretty bad. But if you're following the key, we can do it. So I have an x squared minus 1. Which one does that fall under? Case 1, case 2, or case 3? Well, this falls under case 3, and this tells me that my x is going to have to be a of secant theta. What is my a? Well, this is a right here, 1. Well, the square root of 1 is 1, so I can write it. We'll just write it for keepsake here. I have 1 of secant theta. Easy enough. Let's go ahead and take our derivative. 1, we'll just go ahead and drop them now at this point. So the derivative now of secant is secant theta tangent theta d theta. Okay, moving to step 2, which is to actually plug this in. So let's rewrite this guy. I have the square root of x in this case is secant theta, so parentheses secant theta squared, do not forget your squared, he's applied, minus 1. Alright, this is all over x to the 4th, so I have secant theta to the 4th power. Now we are in terms of theta now, so I cannot use dx. Remember that essential rule, we have to plug it in for whatever is d theta. In this case, we have a secant theta tangent theta d theta. I will sometimes reference this as just 2 hash marks, so I don't have to write it over and over and over. Okay, so let's go ahead and simplify this up a little bit. So what I have here, going over, keep our integral, secant squared theta, big root, secant squared theta minus 1, all over secant to the 4th theta multiplied by this big boy. Okay, so from here we can go ahead and replace with our check mode. So go to the section that says check and make sure that you have what it says. Do we have a secant squared minus 1? We do. It's right here. So we are on the right track. So secant squared minus 1, what does that turn to? Tangent. So this top portion will turn to a tangent theta. Rewriting this. Now remember, the squared gets canceled with our square root. That's how we are left with just a singular tangent theta all over secant to the 4th theta. Now I'm going to write out our hash marks there, tangent theta d theta. Okay, we are getting there. So next step is to simplify as much as livingly possible. So I have a secant here. These are products, so I can go ahead and cross reduce as much as possible. So I have 1 here. I'm going to cut him out. This will go to 3. Multiply my tangents together. This gives me the integral of tangent squared theta all over secant cubed theta d theta. Whew, don't forget that d theta. Okay, from here, what I'm going to do is, I personally hate having a secant in my problem. They're a little hard to work with. You can work with them if you like, but we're going to go ahead and swap this out for what we know. So I'm going to go up here in the tiny little corner. We know that secant is the same thing as 1 over cosine, and reverse. So if I have 1 over secant, that is cosine. So let's just rewrite this. So it's all on the same line. I have tangent squared theta times a cosine cubed theta Oh no, d theta. Okay. All right, so now at this point we can actually work with this. So I'm going to do a u substitution. And before I can do the u substitution, let's go ahead and change tangent in terms of sine and cosine, since we are working now with a cosine. So let me switch over here. Okay. Now, before we do this, let's go ahead and rewrite tangent. Tangent squared theta. Tangent is sine over cosine. So I have a sine squared theta over cosine squared theta multiplied by a cosine cubed theta d theta. Woohoo! These are going to cross multiply, leaving this to 1. So rewrite again. We have sine squared theta times cosine theta d theta. If we had a squared here, we would have an identity. We are just a little bit off from an identity, so that's why we're going to use u substitution. Okay, so for u sub, let's let u equal sine theta. That might help. Du will be a cosine theta d theta. Now at this stage, I'm always trying to check, can I actually use this u substitution essentially? Of course I have a sine theta, that's given, but let's check du. Do I have a cosine theta d theta? Right there. So yes, I can use this u substitution, it is valid. So rewriting again, I'm going to plug in u, so I have the integral of sine became u, so I have u squared, and cosine d theta becomes du. Now this is an easy antiderivative, so let's go ahead and take that. I'm given the antiderivative is plus 1, so u cubed all over 3. We don't want to add on plus c right now because there's really no point yet. But let's go ahead from this stage and undo. So undo that substitution. So simply u was sine. So I have sine cubed theta all over 3. Okay, if you like to write this as 1/3 sine cubed theta, go for it. It's exactly the same thing. It really just depends on how you like to see it. From here, we are unfortunately not done. We have one last step, and that is using a reference triangle. So we want to remember this section, and we're going to move to another page here. So we have sine cubed theta. Sine cubed theta all over 3. And then our initial substitution was secant, 1 secant theta. So let's draw out our triangle, because whenever you do any kind of substitution, trig, you always have to undo that substitution to give an answer in terms of x. So this theta is a problem. He's a problem child. Okay, so we're going to draw out our giant right triangle. This will be theta. So what I'm going to do is I'm going to solve this in terms of that. Let's rewrite this though. I don't like secant. Secant, unless you've memorized these, go for it. All power to you. So the secant is the same thing as 1 over cosine. So 1 over x is cosine theta. That's always handy. So cosine in this case, cosine theta is 1 over x, adjacent over hypotenuse. So let's go ahead and reference that. We have adjacent, which is this guy, over hypotenuse. So I'm just plugging in this and this. Those are not negative, so let me rewrite those. Okay, magic trick. This is always, the remaining side is always going to be that initial square root that you had in the very first portion of the problem. In our case, we had x squared minus 1. So that's how you always know you're going to get it right. Make sure you find your two sides. the remaining side, which is our opposite in this case, will always be that square root that you had substituted for. Okay, so let's rewrite this. I have sine cubed theta. Well, what's sine theta? Before I can do anything cubed, I need to find out what sine theta is. So let's pull out our 1/3, which came from here. We're going to go ahead and multiply in our sine, which sine is opposite over hypotenuse. So O over H. So we have the square root of x squared minus 1, all divided by x, which is our hypotenuse, cubed, all right, plus c. I guess at this point we can add on that c. Now all we have to do is simplify, but to be honest, I don't really want to simplify this. It is in an actual good form, because if you're going on to other courses such as DiffyQs, you will want to keep this in this form. So let's just rewrite it in a little bit cleaner way. I have the square root of x squared minus 1, all divided by x. This is going to be cubed, and we're just going to go right next to it, plus c. So this is our answer, doing a U substitution and a trigonometric substitution. If you follow that key, you are bound to get the right answer. Let me know what you think, solve a couple problems, and leave a comment below, and I'll do my best to answer all the questions you have. And until next time.